right, guys, I'm Nicolette, and today Brian and I are here to talk about charging infrastructure. And we're joined by some experts from Sager Electronics and TE Connectivity to talk about e-mobility and the necessary charging infrastructure that will bring us into the future with smart charging solutions. So we're joined by Juan Duran, Key Account Manager, Industrial BU at TE Connectivity, and Chris Skinner, Supplier Marketing and Product Manager with Sager Electronics. And we'll be discussing the differences between AC and DC charging stations, challenges that design engineers are up against, and some important solutions that will meet the needs regardless of power level or charging speed requirements. So thank you both for joining us. We appreciate your time today.
Thank you for having us today.
Thanks for having us.
All right, Chris, so why don't you kick us off from the Sager perspective and give us kind of like a high level. What is Sager seeing from its customer base around EV charging?
So the EV design market was really undeterred by the pandemic, and that EV explosion in terms of design and possibility is really endless. We're seeing focus from our customers on electric everything from bikes to snow blowers to lawnmowers. Supercharging is a hot topic, current demand, longer driving range. We're even looking at vehicles becoming mobile power sources at some point with vehicle to grid or vehicle to home power flowback capabilities. As a New Englander, it's pretty amazing to me to think that at some point my Jeep is going to become my generator in a blizzard. That would be helpful. Also, charging station safety is a huge component of what we're seeing in the design work from our customers.
So Juan, what are some of the biggest key breakthroughs we've seen recently?
Yeah, thank you. So we've seen a lot of great demand on charging piles from a TE perspective. Smart, slow charging plus high power fast charging. So for example, by the year 2020, AC charging was about 65%, DC charging was about like 35%, and by far DC charging is having the fastest growing rate towards 2040. High power charging piles are growing quickly, as I was saying, and we've seen an intense competitiveness in the market, and therefore a great pressure on cost of the components.
Now, what about safety and reliability? I'm sure there's a lot of concerns around this. So, I mean, Juan, are you seeing any trending, concerns there around safety?
Yes, absolutely. At TE, we treat safety as one of our top concerns. Right? We try to make our components more safer, more reliable, faster, and better every time. And in this case, with AC/DC charging, as we're seeing much higher speeds in charging the pile, AC/DC, the main concern is thermal management. So the charging systems are being built for higher voltage and current increases, and the thermal loads of the EV system is raising up the temperature, right? So it's raising the temperature of the battery, of all of the connectors, everything going inside, and obviously that can create a fire concern or fire issue. So we don't want that. So our components needs to be designed in order to meet not only the customer requirements, but also any safety issues that we might see on the application.
Now, you mentioned current in there. What are some of the current challenges faced?
So, for example, in some of the applications, we're starting to see higher currents, again, higher voltages. This is going to be the only way where the design brands can have a smaller time of charging. So, for example, think about it, like a level 1 charger in your car, in your house, like an AC level 1 charger. That's probably going to take 24 to 48 hours for a full charge. Level 2 might take 12 to 24 hours, depending on the brand, depending on your adjustments. Now, level 3 or DC fast charging, right now, it's going to take probably 20, 30 minutes for an 80% charge. So we need to bring those down in order to make them more efficient, more reliable. Right? if we're going to be taking the next steps in order to move away from oil, then we need our cars to be filled much sooner, much faster.
So you were talking about the different levels, Juan. It might be helpful for the audience to recap what those different levels are, 1, 2, and 3. Maybe just break those down quickly for the audience.
Yeah, it's a great question, Nicolette, and thank you for asking. So, as you can see here on the collaterals, there's different levels depending on the region. So we're seeing 4 like subsystems, 1 for China, 1 for Europe, 1 for Japan, and another one for North America. So each one has their own levels. So for example, North America, as I said, we have 3 levels. Level 1, level 2 are AC charging systems, and level 3 is a DC fast charging system. And the other regions, as we can see here on the collaterals, are going to be a little bit different, right? For example, Japan having CAT-MO, AC/DC. China has their own subsystems, so it's better explained on the percentage.
Can you discuss a little bit about the difference between AC and DC charging?
Absolutely. So again, it's going to have to do with the thermal requirements, having higher current and voltages, and something that we at T takes it's very important, and it has to do with miniaturization, right? So level 1, level 2, it's something that you can carry around in your car, right? So normally if you go out and buy an EV from any dealership, it's going to come with a level 1 AC charger. So you can just plug it on your house or your family's house, anywhere you go, and it goes into direct outlet 112 volts. Now, level 2, that's going to require a little bit more in terms of installation. So it will have to probably be installed back in your house to 220 volts instead of 110. And it's going to deliver a quicker, faster charging because it's handling more current and more voltage. And now with DC fast charging system, right, this is going to be like high voltage. And now it's going to be DC, so it's going to have some integrated batteries inside, right? So that makes the charging much faster and much efficient than your regular AC charges.
So Juan, can we also go a little bit deeper into speed and voltage differences?
Yes, absolutely. So let's go through the differences in level 1, level 2, and level 3, right? So as I was discussing, level 1, the application plugs into the wall, into any wall. Voltage is going to be 120 volts AC. Amperage is going to, we're talking about 16 amps. And in terms of power, we're using like 1.9 kilowatts approximately. Now, level 2 is going to be a little bit higher, right? So it's more of a charging station into your garage, something like that. Mm-hmm. And it's going to be 240 volts AC. Now, in terms of amperage, it's going to 80 amps. In power, now we're using 19.2 kilowatts. And now the level 3 or DC fast charging, right? Now this is one of the biggest charging piles that are going to be replacing gas pumps in the near future. And in terms of voltage, we're going from 300 volts to 1,000 volts DC. In terms of amperage, we're going between 50 to 500 amps. And in terms of power, between 50 and 500 kilowatts. So as you can see, that what makes the difference in terms of the charging, right? The more power, the more amperage we're delivering, the faster we can charge the car. And that's why one of the main concerns that we were discussing a little bit earlier, it has to do with thermal management, right? So the more power, the higher the temperature, and we need our components to withstand those high temperatures.
So another question, why opt for AC versus DC?
That's a good question. So it's going to depend. So AC is going to be more like, again, plug and play, right? So more into residential. Anyone's probably going to have one of these on their houses, and more like commercial destination work kind of style, right? So right now, if you go to the grocery or something, you're going to see those piles there. Those are going to be AC level 2, and everything back in your house might be level 1, level 2. But now, if you're taking like a road trip, right, and you need faster charging, then you have to go through one of these DC fast charging piles. Right? Why? Because you don't want to stay there for 10, 12 hours charging your car, right? You want to be there 20, 30 minutes and then continue with your trip. So again, right now, DC fast charging stations are delivering about 80% between 20 and 30 minutes charging time.
So it seems like DC is going to obviously replace regular gas stations, where AC is going to be mostly home use. Is that what we're predicting?
Yeah, that's somehow accurate, right? So AC is going to be home, work, and destination, versus DC is going to be more in terms of the EV infrastructure moving forward. So with all the incentives from different governments and with the projections towards 2040, right, of having at least half of the vehicles in North America being EV, then that's where we're going to start seeing more DC fast charging stations a lot across the country.
You know, you mentioned infrastructure. Juan, why don't we talk a little bit about the infrastructure and restraints? We're not there yet. So what needs to happen to get infrastructure set up for all of this?
That is a very good question, Nicolette. And it's kind of funny because it's like the egg and the chicken dilemma. What was first, right? So the dilemma is, what needs to happen first? Start building the infrastructure, right? All of the DC fast charging stations across the country, or first build the EVs without having the DC fast charging stations. So that has been the dilemma so far, and I guess that's where we're starting to see some middle ground between. All right, we're going to start building XY amount of EVs and XY amount of DC fast charging stations. But I guess a lot of has to do with the breakthroughs that Chris was talking about at the early conversation. And then secondly, all the investments, all the foundings from the government right now.
So why is it important to have testing standards and things like the UL certification for, EVs?
Yeah, that's a very good question. So as you know, everything in the US and North America needs to be certified by UL. The United Laboratories, they are the ones who dictate all of the norms and standards and pretty much everything that has to do with electronics and electrical. So why is that important, right? Because talking about, from an initial conversation, safety. And again, safety is a very, very strong element at TE with everything that we make. So I think that just regulates the level of safety, the level of testing that our components are going to be meeting and requiring if it's going to the market. What do I mean? If you're going to be plugging your EV, right, into your charging system back at home, you want that to be as safe and reliable as you can. Right? You don't want to run into any issues, any fire hazard, any other type of security situation, right? So TE is very dedicated, again, to safer, faster, better technologies and components.
So Juan, how is battery charging changing storage?
So we can see this from different perspectives. For example, in terms of EV charging, right, DC fast has integrated batteries. So again, that it can provide a much higher current and voltage. And it's DC, so we have minor rest in terms of how the current is flowing towards the EV. And the other thing is that we've seen also a big increase in terms of the battery storage systems. So what do I mean with the increase of lithium-ion batteries pretty much in every of the EVs out there, right? We're also seeing a lot of lithium batteries under storage systems for the electric utilities in the US and across the Americas. So what do I mean with that? For example, you're having like one of your utilities, right? It's a gas turbine that is producing X amount of kilowatts or megawatts per hour.
Mhm.
So during nights, those megawatts per hour needs to go down because the consumption of electricity is less than, for example, when we start waking up in the morning and everybody starts turning lights on, their like mini splits and ACs and all of that, right? So what's happening now is that the factory, right, the factory can start producing like the same level of megawatts. When the consumption is lower, it can start charging the batteries. And then when we have peaks in the morning, those batteries can be discharged. So the level is kind of a little bit normal. So that's why we're starting to see a lot of batteries or storage systems on the electrical side.
Right. That way it's not everything pulling the same draw at the same time. You know, you're able to use that almost as a backup, really, of energy.
Correct. A backup, and it's also a way of having more electricity. So when we have peaks on the grid, right, those
Right.
can discharge from the batteries instead of I don't know, causing some other issues at the industry.
Right. So now, EV charging generates a lot of heat. How is cooling being handled? Right. We're talking about a lot of power going through some of these things, a lot of electricity.
So yeah, right now, in terms of heating or dissipation, we're seeing fan dissipation. So it's just a regular fan and some of the DCs. Now, again, as technology is improving and we're starting to see more current, more load, more voltage, then some of the improvements are liquid cooling. So what do I mean by that? We're taking the fans away, right? And then on the application, there's a certain liquid cooling, like a refrigerant, like in the cars right now, and it's going towards the batteries and all of the different components inside. So what that means is that temperature can increase, but that liquid cooling is going to take that temperature down. So again, making a little bit more progress in terms of the thermal management.
Reducing the heat. Yeah.
So, how are TE's products designed for each charging range?
So yeah, that's another very good question, right? And that's why our portfolio is very broad. So depending on the type of, talk about EV, depending about if we're like using level 1, level 2, level 3, it's going to be the type of components. So we have a product family for a relay, but in that product family we have X amount of different components that are going to be withstanding different temperatures, different loads, right, and different cycles. So depending on the design from the customer, what are they looking for in terms of requirements, right? We're going to be trying to meet those requirements using some TE components.
So what about the future of EV charging, right? What should engineers be thinking about now to build out this new future that we've been talking about for the last half hour?
Yeah, so, and again, I guess it goes back to Chris's initial statement about electrification. Certainly, personally, I believe that electrification is the future of the world. So in terms of electrification, again, in order to achieve an electrified world, it's going to be based on, again, thermal management, and those thermal management supporting higher loads, current and voltage. So if design engineers, component engineers find a way to mix that higher loads with lowering the temperature, as I was talking right now about liquid cooling, then that's where we're going to see the future of EV charging, right? So eventually going into a charging station, one of these infrastructures replacing regular gas stations, and hopefully getting to just plug your car, couple of minutes, and then continue with your road, with your trip.
Now, Chris, you work closely with TE here, over at Sager. So, I have a question for you. How are you guys really supporting the growing EV charging market demands?
So we've been fortunate enough to be a TE partner for many, many years, and we all know that lead time is of paramount right now. So Sager has made investments in a wide variety of TE standard and up-and-coming products to ensure that we have the inventory in place to support our customers, both from the production and the prototype stages. So if you combine Sager's 135 years of history and proven expertise with TE's broad portfolio of products for the EV charging application, it's a win-win for everyone, most importantly, the customer.
All right, guys. So thank you so much for talking to us today about, developing a charging infrastructure, with the help of these smart charging solutions. And we appreciate your time. But before we let you go, we'd love it if you could leave us with some final thoughts on this topic.
Yeah, thank you, Nicolette. And again, it's been a pleasure being here today. Thank you for having us today and talking a little bit about EV and how TE is helping design and promote in terms of electrification. So as we said, electrification is the future of the world. And it's not only on EV or battery energy storage systems. So electrification is going to be covering pretty much everything. So yes, EV is going to be like first more demanding, right? Charging systems and all of that. But then everything else behind it's going to be becoming more electrified or electrification. So we're seeing a whole other bunch of different applications that are going to be becoming electrified in the near future. And now, if you want to learn more, or the audience here, so you can always log into te.com and go into our EV landing page, which we're going to state here. And there's a lot of useful infographics and information about EV battery storage systems and what TE is doing towards electrification or more electrified future world.
All right. And Chris, we can find some stuff on Sager's website as well, correct?
Absolutely. This is a really exciting market, and thank you for having us. And you can look on Sager.com for more information as well.
Awesome. We are excited about the future.
That's right. Need more chargers out there. road trips, I tell you.
Thanks again, guys, for your time.
Thanks for having us.
Thank you, everyone.